And we will move on to the next speaker, which will be Adayana Silva. So she will present the work named WRF Model Assessment to the Wind Profile and Thermodynamic Characteristics during the chuva project, Alcântara Station 2010.
Good afternoon, everyone. My name is Adayana Gomes. I will present you a part of the studies of my master's degree that have finished that are 2 months ago by INPE, among with my advisor, Dr. Gilberto Fisch, by IAE. The WRF Model Assessment to the Wind Profile and Thermodynamic Features during the chuva project at Alcântara Station 2010. The main objective is to evaluate the WRF model performance and predict the vertical wind profile before occasions of rocket launchings at Alcântara Launching Center, from now on called CLA, as well as its confidence in hours intervals by comparison against observations. And this analysis is up to the first layer of 5,000 meters, because that's the height of most likely influence of the wind in the trajectory of the rocket. The CLA location is at just 2 degrees south latitude, and it can be seen at the picture. It is very near the coastline of the ocean, and the region is of mostly flat topography, but there is a 40-meter coastal cliff between the land and the beach. About the climatology, according to Fisch and Barros and Oyama, the rainy season goes from January to June, and the precipitation occurs mainly in March and April. At this season, the sea breeze is very weak, and the winds are composed basically by the trade winds. So at this season, the winds are in general weaker. The WRF model was configured to 3 domains with square and centroid at Alcântara, and they are represented at this picture, and they have this size with respective horizontal resolution of 93 and 1 kilometer on the most inner domain. All of them have 42 vertical levels. The terrain was initialized with data from USGS and the initial and boundary conditions from GFS and STEP. The time step was 5 times the horizontal grid spacing. The spin-up time was 6 hours, and the runs had 72 hours of integration time, with model outputs every 6 hours. That was the machine of work, and these are its configurations. It is installed at IAE. the model results, we used observations data from soundings and from X-band radar at PPE mode for the period from 19 to 25 March of 2010. The comparison was made by 3 statistical index: the bias, root mean square error, and the Wilmot index of agreement, or from now on, just Wilmot. They were calculated every 6 hours to the total wind speed, or VEL, and to the U and V, the zonal and meridional components of the wind. In the first part of these results, the results showed no superiority among the components U and V with respect to the Wilmot index. Wilmot achieved the maximum values of about 0.95 for both components. But for errors, the U component has values generally larger. About wind bias, it reached up to 3.80 meters per second, like here. And about root mean square error, U reached up to 4 meters per second, like here. At these graphs, there are time series of the average of the components U and V among the layer of the first 5,000 meters. Here is the pure variable with no statistical index applied. And for this period, we can note that the model overestimated the U component of up to 3 meters per second. But about the V component, it was satisfactory. Well, in the second part, we know that the rainfall pattern influences the wind pattern and vice versa. So, we evaluate the thermodynamic consistency of the model results by checking the space-temporal coincidence of the rainfall, comparing the accumulated precipitation fields in 1 hour from the model against images from X-band radar. In general, the WRF model was not able to represent satisfactorily the position, the intensities, and the time of precipitation score. In a first example, heavy rainfall was observed by the radar over the CLA for about 15 hours, almost non-stop, with about 60 dBz, but none of the runs that included this time interval was able to represent such an extreme event. Here, March 21, 18 o'clock, in the radar, a strong precipitation, but nothing in the model. Here, the strongest core over all the region at 22 UTC, but very little in the model. In the end, 2 core observed by radar, and then the model starts to some representation. This is at 22 March, 6 UTC. In a second example, tracking the trajectory of convective systems that moved over the area of the simulation domain, it was possible to note that the model had a delay of about 2 hours. Here, the model represents the precipitation between 12 and 13 UTC. But its observation by radar had before between 10 and 12 UTC. So this suggests a delay of the model of about 2 hours. We concluded that it wasn't possible to obtain a time interval pattern of all simulations where the quality of the predictions was better or worse. And according to the Wilmot Index, the model was reasonable to represent the vertical wind profile within the limitations that all models have, but they achieved maximum values of the order of 0.90 and on the average of the order 0.70. That were considered satisfactory according to limits found in other studies. And with the default configuration of cloud microphysics, the WRF model fails to capture the presence of rain in terms of position and intensity, mainly. And this issue must be better studied in future works. And just remember that these are just a part of my master degree that have finished in last February. That's it. Thanks.
Many thanks, Adayana, and we have time for questions, comments. Henrique, por favor.
Let me remember. I didn't have here. If I don't remember, I can see, and could I answer you after?
Another latitude is again 2 hours delay time. The model is
I think that's Cambridge. I think.
Another questions that you may answer, Henrique, is that can you explain a little bit about the parameterizations that you have used for boundary layer?
Yes, I made some tests just for boundary layer, planetary boundary layer parameterizations. I've tested 4 kinds of them, and the 2 better were, do you know, MYNN and ACM is Mallory Yamada, Nakanishi, and Niino, and asymmetric convective model 2. These were the 2 better of the 4 tested. No. This part of thermodynamic features, I've tested just to Mallory Yamada, Nakanishi, and Niino, because this parameterization was used to the rainy season and the other to the dry season.
Any other question? Okay, thank you, Adayana, again. Just to remember all of you that Alcântara was the first field campaign of Projeto Chuva. It was held in 2010, and then in 2011 was Fortaleza, Belém, and Vale do Paraíba, and then 2012 Santa Maria, and 2014 there will be Manaus, Central Amazonia. Okay.